intelligence.
Show your hands. How many of you are familiar with artificial intelligence?
Okay, so you know something about it, or has anybody taken a class in AI?
Maybe just some guest lectures they have attended, not much.
Okay. Okay. So everybody can see my screen, the next screen here?
Yes.
Yes.
Okay, great. So in this screen, I have a little, I say AI is becoming ubiquitous, and that means we're starting to see its applications everywhere. Let's see. And so on the top left here, AI is being used to do object detection. That is, given an image or even in real time with video, it can detect all the objects in the scene. It can classify what the object is. It can draw bounding boxes around the object. This is actually very useful for things like self-driving cars. In the bottom right, this is the Google self-driving car, and so that's there's a whole trend towards cars that will be able to drive themselves. Even in America, there are certain areas, like in Arizona, that they're already testing these self-driving taxis and things like that. Artificial intelligence, a big area of artificial intelligence is something called natural language processing, and that is if you've ever used like Alexa. You guys have heard of Alexa?
Have you heard about it?
Yes, or if you've used on iPhone, there's something called Siri. If there, Google has something called Hey Google, and this is artificial intelligence that can. Oops. Excuse me. Sorry, I'm getting a call here. All right. So these are artificial intelligence systems that can understand speech. So you can speak to devices and they can understand what you're saying. I have these in my house. I have Alexa devices that I can tell to play music or turn on the air conditioning or set the alarm or all kinds of things. Uh, Artificial intelligence is also being used in biometrics, and so things like if you want to use your face as a like on my phone, I have to use it scans my face to unlock the phone now, and or scanning your fingerprint. Those kind of things are biometrics. Those also use artificial intelligence, and in many other areas, artificial intelligence is becoming popular. So there's a quote that's becoming famous now, and the quote is by a man named Andrew Ng, which is he was a professor at Stanford University, and he's also co-founder of Coursera, which is an online learning system where you can take classes from many top universities. And what he said was, AI is the new electricity. And I want to read this quote. I want to read this quote from Andrew Ng. He says, about a century ago, we started to electrify the world through the electrical revolution. By replacing steam-powered machines with those using electricity, we transformed transportation, manufacturing, agriculture, healthcare, and so on. Now, AI is poised to start an equally large transformation on many industries. For example, the IT industry is totally transformed by AI. FinTech, which stands for financial technology, is also being totally transformed. Healthcare is starting to be, and there is huge opportunities there. Self-driving is an industry built on AI. Other industries like search engines and food delivery are also supported by AI. The only industry which will not be transformed will probably be hairdressing. And just looking at that, I was thinking about how about the field of mathematics? How many of you will stay in mathematics? You think your whole career, like you'll be a mathematician, or you'll work, you'll teach math? Can you get?
Stays with math. Raise your hands.
Okay, so quite a few of you. Yeah. So what I'm going to make a prediction here is that, and I'm going to show you some very recent papers near the end, is that AI and math are going to be very closely related, and just to be on the top of your field in the future, you're going to have to know something about AI. Okay, so an overview of my talk. First, I want to give a basic introduction to artificial intelligence and the main modes of the main categories within AI, such as supervised learning, unsupervised learning, generative adversarial networks, and reinforcement learning. And then I want to talk a little bit about the math behind AI that's really enabled AI. And I'll get into like the universal approximation theorem, stochastic gradient descent, and things like adaptive moment estimation. And then I will talk just briefly about AI for math, and that is how AI systems are being built to solve math problems. And one of the really exciting papers that just came out in December of 2019 was on deep learning for symbolic mathematics. There's in the last 1 to 2 years, there's been work in neural uh, ordinary differential equations, and also a whole area that's emerged called physics-informed machine learning, which is really exciting. And so this is a question I pose: is although there has been research in AI for more than 70 years, how did AI become an overnight sensation until just the past few years? So until really about 2012, the people that AI was not very widely popular. Now it's become extremely popular almost overnight. um, Actually, there's a man named John McCarthy, and he coined the term artificial intelligence in 1955. So this term's been around for a long time, and there's been a lot of talk about it. But I feel like it's a little bit like if you've heard the phrase quantum computing. There's a lot of talk about quantum computing now, but it's not very popular because it can't solve very practical problems yet. But what happened was that um, since there is a competition that's held, um, uh, there's a competition that's held every year called the ILS VRC, and basically it's a competition for building AI systems um, to recognize objects and images. And in 2012, they these guys, Krzyzewski, Sutskever, and Hinton, Jeffrey Hinton. Jeffrey Hinton's the main guy behind deep learning. Um, they developed an algorithm to um, they developed an algorithm based on deep learning. Before that, they were using machine learning algorithms, and also they started using something called convolutional neural networks, which I'll explain later. But you can see this is an error in predictive accuracy, and so this means back in 2010, uh, when you could, let's say you gave a computer a picture and you said, "Tell me if a cat's in this picture," and it could only tell you with about 70% accuracy whether that there was a cat in the image or not. Which meant in 2010, which was 10 years ago, computers were much worse than humans in being able to tell you what was in an image. Well, you can see every year this is dropped, and this was a pretty significant drop from 2011 to 2012 when they started using deep learning algorithms with convolutional neural networks. But you'll see something interesting by 2015. Actually, this is the red here is human level performance. So this is how well humans, if you were to ask, a number of humans to tell me what's in an image, there's still an error rate associated with what they'll tell you, and so I don't know. That's on the order of I guess around 5%. So in 2015, what this shows is that that an AI system was able to beat humans in telling what was in a picture. So that was a very significant event in terms of artificial intelligence, because that means that artificial intelligence systems have become better than humans in telling us what's in image. And basically, it means we figured out the mathematics how to solve this kind of problem well. And if you think just in terms of like medical sciences, okay, reading and reading a CAT scan or detecting if someone has cancer, just now that AI systems are being able to do that have surpassed physicians in being able to detect if a person has cancer by reading their radiological scans. And so that's a very significant event. In 2016, this is an article from BBC News in 2016, and this says that Google achieves AI breakthrough by beating the Go champion. So the reigning Go champion was a man named Lee Sedol from he was from South Korea, and he was the world champion for something like 19 years for this game of Go. And I don't know if you've ever heard of the game of Go, but it's one of the most difficult games to play. And the number of possible moves, there's more possible moves in the game of Go than there are atoms in the universe. So it's a very complex problem. But the actually Google has a company called, they bought a company called DeepMind, and DeepMind thought, if we're really going to prove that our AI system's going to work well, our AI system has to beat the the world leader, the world master of Go in the hardest. This is like the hardest game, the hardest traditional game, I guess you could say, that's existed. There are some like online games that are more complicated, but as far as an old, this is like a 4,000-year-old game. And when they went in to play the AI against Lee Sedol, he thought, well, the AI may win one game, one or two games, but I'll probably win most. Like they played 7 games, and and actually Google's DeepMind, they didn't know how well their AI would do. Um, it it beat Lee Sedol, I think 6 games. He only won, I think, 1 game. And after he played the after game 2, he said, after the first game, he said, yesterday I was surprised. He said, today I'm speechless. And as of in November 2019, Lee Sedol retired, stating that AI is impossible to overcome. Even if I become number 1, there is an entity that cannot be defeated. And so this has actually become a reality, that AI has surpassed humans in being able to do certain tasks, such as play games. Although games are typically used as a metric to see how well AI can perform, but the end goal for AI is not just games. It's like building self-driving cars and those kind of things. That was 2016. 2 years later, 2018, an article came out saying OpenAI's bot handily beat a team of professional Dota players. So a single AI beat 5 people playing together a strategy game, online strategy game. And this was using a technique called multi-agent reinforcement learning. And then in 2019, Google's DeepMind, there's an article that came out, Google's DeepMind AI beats professional human StarCraft 2 players. And so to put this in perspective, these are a list of games here, and you can see the year. And this is basically when the AI was able to defeat humans. So, okay, tic-tac-toe, one of the simplest games, and AI was able to beat humans in 1952. We get down to like chess in 1997 with IBM Watson, and, and then Go was 2015, and I don't know about this game, and then StarCraft 2019. And you can look at the state space complexity, how complex this is, and how sophisticated these AI systems are becoming. And so what I'd like to do now is just to talk about several of the different categories within artificial intelligence. And so basically you're creating a machine that you're going to teach how to do something. And there's several categories and there's several ways to learn. So if you think about just yourself, you may learn, if you want to learn a subject, you may go buy a book and you may read a book and you may learn a subject. Or some people say, well, I'm not good at book learning, I just learn by experience. And so there are different ways to train AI systems that are basically modeled after the way we learn. So supervised learning is basically by studying examples. So you have a bunch of data, you give a bunch of samples of data to your AI system, and it learns, it basically learns a mapping between your features in your data set and your labels. And I'll explain a little bit more about that. And then there's unsupervised learning. And unsupervised learning is really learning to discriminate, learning how to cluster things. And so learning how to group things together. And so in unsupervised learning, basically you're given a bunch of data, but you're not given any labels related to each of those samples to tell it what that sample is. So you don't know how the data is organized. I'll talk a little bit more about that one as well later. There is something called a recent technique since 2014 called generative adversarial networks that have gained a lot of popularity recently. And these are basically learning by competition. So pitting two AIs against each other. And you can think of, you may play a game like tennis or some game, and by playing the game, you may learn new strategies in order to defeat the other person. And then there's reinforcement learning. And reinforcement learning is learning by trial and error. So this is simply trying something. If it doesn't work, don't use that, and just keep trying different things and see what works, and what doesn't work, forget those things and keep the things that work. So as far as supervised learning, so if you're given us samples of features as a set of vector X and labels as either a scalar or a vector Y, basically what you want to do is you want to learn a mapping such that basically you can give some sample X and it will give you it will return some label. And so what we're talking about is just learning this function, but we're talking about a universal function, which I'll talk about in a minute. Here's an example. So suppose you wanted to be able to predict the shoe size of a person, and what features you're given are their height, gender, and weight. And so what you may have is you may have a set of so a vector X consisting of height, gender, and weight, and you may have many samples here, and then you may have a label which is their shoe size. These are European size, and so you train your neural network with all the training data because it's supervised. you have both a set of features X and you have a label associated with that feature. And basically, you want to train your neural network, and then you want to be able to give it uh, a feature, and you want the AI to be able to predict what the shoe size is or what the label is. And so that's at a very simplistic level what uh, supervised learning can do. There are a number of other kinds of problems. So, for example, a popular problem is being able to predict the probability of someone clicking on an ad. This is very useful for people that actually, when you go to the internet, and companies like Google or a lot of different companies do this, is they want to be able to put ads in front of you that you'll have a high probability of clicking. And so in order to do that, they actually, a lot of these sites use machine learning to be able to predict ads that you'll have a higher probability to click on, because these ads, people like companies like Google, they actually get revenue based on ads clicked. So they want to put the most probable ads that would be clicked in front of you. And so in this case, you may have a set of features like the ads historical performance, the advertiser and ad content info, the publisher info, and user info. So if you have information about what previous things the user has clicked on, then that gives that also is very useful information to be able to predict the probability that that user will click on some other things. Um, and so the target in this case would be the probability of a user clicking a link. For unsupervised learning, so you're given a set of data. So you're given the X vectors, but you're given no Y labels. And so essentially the goal is to learn to discover clusters or classes in the data. Sometimes this is called segmentation, so segmenting the data set. Um, and there are many different approaches. There's like k-means clustering is a simpler approach. But one of the popular methods today in unsupervised learning is something called variational autoencoders. And I'll show you an example of that. But some examples of unsupervised learning is like anomaly detection. So you want to detect, if you have security data and you want to detect somebody that's hacking into a system, or you want to detect somebody that stole a credit card and they're using the credit card to buy things that you wouldn't normally buy. So actually, many banks are using artificial intelligence to be able to do fraud detection and be able to detect when purchases are used by like a stolen credit card. So as far as autoencoders, the basic idea behind autoencoders is your input and your output are the same, and you're trying to learn a latent space representation for your image. And so by running your by running your input image and your target being the same image, actually you're learning to represent that image in a smaller in lower dimensional space. And what happens when you do that is it actually learns the most important features to represent that image. And as I mentioned, so there are a number of different uses for why you might want to use this type of approach. It's one method of data segmentation, but it's a very powerful one. I'm going to show you an example. This is an example of something that one example that what autoencoders can do. Now there's a interest if you have photographs and you have obstructions in the photograph. So here's an eye with a cross through the eye. One thing that autoencoders can do is you can give it that this type of input, and it could reconstruct what the original image might have looked like. and so remove the obstructions from the image. And these this is a really popular architecture. So this is getting a little bit deep, but when it comes to autoencoders, a lot of people are using this UNet architecture, which is a complicated architecture to be able to do this kind of autoencoder learning. So I think you'll get these slides, and you can look up if you're interested in any of these. I have links for each of them down at the bottom, so you can find further information. Now I want to move on to reinforcement learning. Reinforcement learning is has been studied for many years. It's probably older than some of the other techniques, and it's based on research in behavioral psychology. And it's basically based on the concept of learning by trial and error. So if you have a baby and it touches something hot, it quickly learns that hot is bad. I mean, in the sense if it's really hot. And so the idea